Tell me which one? That bullet question we discussed, right? That suppose there is a wall, and bullet is coming with speed v. Bullet is coming with speed v. So what is the initial momentum? Sorry. What is the initial momentum? Initial momentum mv. If it is absorbed, suppose it is absorbed. So what is the final momentum? 0. So what is change in momentum? Minus mv. Final minus initial. So force is equal to delta P by delta T, correct? So minus mv by delta T. This is force on bullet. Force on one bullet. Force on one bullet. So what is the force on wall? What is the force on wall? Plus of this. So force on wall will be mv by delta T, correct? If bullet is experiencing force left side, so wall will experience force right side. If n bullets hitting per second, then what is the force? Then force becomes, correct. So n times of this, so n by delta T mv. Now this is known as number of bullets per unit time. So delta T will be 1 second. So F will be nmv. N is number of bullets per unit time, or number of bullets per second. Number of bullets per second, correct? So when the force nmv, force is nmv when the bullet is absorbed. When the bullet is absorbed by the wall, bullet is absorbed, bullet is embedded, okay? Embedded means it will come to rest, it will come to stop, it will come to stop. So force is nmv. What if it is not stopping, it is rebounding? So suppose initial velocity is v, and after rebounding velocity is v. After rebounding velocity is v. Only direction reversed. Previously what is the direction? Right side. Now what is the direction? Left side. Now what is the change in momentum? m delta v. So delta v final minus initial. Tell me, minus v minus, yes, correct. So total minus 2v, correct. So what is force on bullet? Force on one bullet. Force on one bullet is equal to m delta v by delta t. So m into minus 2v by delta t. So force on wall, what is the force on wall? 2 mv by delta t. Force on bullet is minus 2 mv by delta t. So force on wall is 2 mv by delta t, correct? And if n bullets are hitting per second, if n bullets hitting per second, so small n is equal to n by delta t, again we can put. So what is the new force on the wall? So force on wall n times of 2 mv by delta t, and n by delta t is n. So, what is the force? Small n into 2 mv. So, force is equal to 2 times of nmv. Okay, clear? Remember this. If bullet is absorbed, then what is the force? If bullet is absorbed, then what is the force? nmv. If bullet is rebound, then what is the force? 2 nmv. 2 nmv. Clear? So, one question is there, the disc question, question 2. What is the question? It is very important question. There is a disc. This is the disc. Okay, like this disc is there. If you release this disc, it will fall. Why it is falling? Because of weight, mg. Anything if you release, it will fall, correct? So, disc will also fall. But according to question, what is written? Kept floating. Kept floating means rest, horizontally rest like this. Okay. So, kept floating. So, net force, what is net force? 0. Net force 0. How it is kept floating? Bullets are fired. Suppose these are the bullets. Okay. These bullets are fired with what speed? Speed is given. Okay, you have to find speed. Okay. So, bullets are fired like this. Bullets are fired. Correct. So, what is the direction of force on bullet due to hitting the disc? Bullet will experience force where? Downward. Very good. And disc will experience force where? Upward. And it is written, if bullets rebound with same speed. Bullets are rebounding with same speed. So, what is the force on the disc? 2 nmv. Okay. 2 nmv. And small n is number of bullets per second, is equal to number of bullets hitting per second. Number of bullets hitting per second. Okay, clear? So, now equate these two because it is at rest. So, net force 0. Floating means rest, remember. If any object is floating, then it is at rest. Like in water, lake, boat is there, boat is floating. So, what is the net force on boat? 0. Okay. So, now you can solve this. So, this is 2n. Now, what is a small n? 10, rate of 10 per second. So, is mass of bullet 0.05 kg into V is equal to capital M into G. Now, capital M is mass of disc. So, 1 into G. Solve this. So, V is equal to 1 by, now this is how much? 0.1, correct? 0.05 into 2 is 0.1. So, into is equal to 1. So, V is equal to 10, correct? Note down 10 meter per second. I have taken G is equal to 10. So, 10 you are getting, if you take 9.8, here if you take 9.8, so you will get 9.8. Okay. So, any other question? What about first question? Book is lying on table. What is the angle between action of the book on the table and reaction of the table on the book? This is the surface. This is table, surface, book is kept, this is the book. So, table exert normal force on the book. What is the direction of that force? Upward. So this is the normal force on book from table. Okay. Now the table surface also experience force reaction. So that is the normal force on table from book. So what is the angle? 180. No, 180 degree. 180 degree. Action reaction. They are action reaction. Correct or not? Oh, answer is 0. Okay. No. Change it. 180 degree. 180 degree. Answer is 180 degree. Okay. Note down. Correct the answer. So these are action reactions. This is action, this is reaction. Action is acting on book, reaction is acting on table. What about third question? Third question clear, everyone? Newton applied to mass 10 gram for 10 seconds. Use the formula F is equal to m delta V by delta T. Okay, average force. So average force is 10 Newton. Mass is given 10 gram. Now convert gram into kg. 10 into 10 power minus 3. What? Delta V. Okay, you have to find change in momentum directly. Okay, this is change in momentum. Delta P by delta T. So 10 into F into delta T. 10 into delta T, which is 10. So what is change in momentum? 100. Okay, note down. Fourth question. Block of mass 4 kg placed on rough horizontal surface. So this is 4 kg. It is rough surface. Hanging block is 2 kg. This is 2 kg. This is pulley. 4 kg is kept on rough surface. Coefficient of friction is given 0.6. So mu s is given 0.6 for 4 kg and surface, horizontal surface. Okay. This is the horizontal surface. Acceleration you have to find. So what is the condition that they will move? They move. What is the condition? Tell me. Correct. Mu s is less than m2 by m1. This is m2. Hanging is m2. Resting is m1. And they will not move. They not move if mu s is greater than or equal to m2 by m1. Correct? So what is m2 by m1 here? 0.5. m2 by m1 is 2 by 4. So 0.5. So mu s is greater. Mu s is greater. Mu s is 0.6. Okay. So mu s is greater than m2 by m1. So they will move or they will not move. Not move. Not move means what is acceleration? 0. Note down. Okay, we have done this yesterday. Fifth question. Block has been placed on inclined plane. So this is the inclined plane. Angle inclination theta. Angle of inclination theta. Block slides with constant speed. constant speed it is coming, constant speed Newton's first law. What is the net force? 0, acceleration 0. It is coming down with constant speed, so acceleration 0. Now what is the downward force? mg sin theta. And what is the upward force? Friction. Kinetic or static? Kinetic. Good. So this is kinetic friction because movement is there. Both are equal. So coefficient of kinetic friction they are asking. What is the formula for kinetic friction? Kinetic friction formula? Mu k n. And how much is n? N is how much? Tell me. Mg cos theta. So they are equal. So F is equal to mg sin theta. So mu k n is mg sin theta. So mu k mg cos theta is equal to mg sin theta. Mg cancel. So mu k is tan theta, correct? Mu k is tan theta. Mu k is tan theta. Velocity of bullet becomes 1/3 after it penetrates 4 centimeter. So suppose this is the wooden wall. Now we have a direct formula for this. Suppose bullet is entering with V. After traveling x distance, velocity becomes V by eta. After traveling further y distance, velocity becomes 0. So what is the formula for y? X by eta minus 1. Very good. Eta square. Yes, correct. Good. Eta square. So x value is given 4 centimeter. So after traveling 4 centimeter, the speed is becoming 1/3. It means speed is becoming V by 3. So eta value is 3. Eta value is 3. So y value is 4 centimeter by 3 square minus 1. 4 centimeter by 8. So 1 by 2 centimeter. So 0.5. 0.5. Note down. So y is 0.5. So they are asking the bullet stops completely after traveling 4 plus x. They are calling this as x. So that is 0.5, correct? 4 centimeter plus some extra distance. So 0.5. Seventh, player catches the ball. Suppose this is the player hand of the player, okay. Ball is coming like this. So what is the initial velocity of the ball? 20 meter per second, okay. So ball is coming like this. So what is the final velocity of the ball? 0. Now v is equal to 0. Now F is equal to delta p by delta t. So m delta v by delta t. Use this formula, you will get what is the final velocity? 0, initial 20. So use it. Mass is given 200 gram means 0.2 into 0 minus 20. You can assume this is straight line. This is the straight line. Along this line it is moving. By delta t, time of catch is this. This is time of catch. Ball will come you are holding, and finally you will do like this, finally velocity 0. So, here to here, okay, like this you are catching. Okay, 8th question clear? 8th, any doubt in that? 8th, acceleration of pulley is what? G. Two masses M1, M2 connected by light in extensible string. Pulley moves up with acceleration G. M2 greater than M1. Now, this is the string. Here you have connected M1. Here you have connected M2. So, tension will be same. Here tension T, here tension T, string is same. So, okay, so same tension everywhere. String is same tension. Now, so M1, what is the downward force on M1? M1G, upward force T. For M2, what is the upward force? T, downward force M2G. Now, in option they are asking, third option they are asking magnitude of acceleration, magnitude of acceleration of mass M1 with respect to ground. So, M1 is greater, no, M2 is greater. M2 is greater, so you assume the acceleration of M2 is A2 and acceleration of M1 is A1 upward. Okay, I am assuming magnitudes. Why I am assuming different acceleration? Because this pulley is also accelerating, pulley is also going up. If pulley is not going up, suppose pulley is fixed. If pulley is fixed, then if suppose this is acceleration A downward, so this is acceleration A upward, and this you know direct formula. What is the direct formula? M2 minus M1 by M1 plus M2 into G. Okay, this is different case when the pulley is fixed. Pulley is fixed, but here pulley is not fixed. Pulley not fixed, pulley not fixed. Now, pulley is not fixed. So, what? How will you solve now? Tell me. So, different acceleration. Okay, understood? So, with respect to ground, these are with respect to ground. With respect to ground. So, these 3 points. These 3 points. You can call it point 1, point 2, and point 3. So, what is the relation between accelerations? A1 vector plus A2 vector by 2 is equal to A3 vector. Now, A1 vector is A1, A2 vector is minus A2, this is a magnitude, by 2 is equal to A3, A3 is G. So, A1 minus A2 is equal to 2G. Okay. So, this is one equation. Now, for M1 what you write? T minus M1G is equal to M1 A1. For M2 what you write? M2G minus T is equal to M2 A2. Now, add, if you add these, so M2G minus M1G is equal to M1 A1 plus M2 A2. Okay. Now, substitute. So, we have discussed this before. Okay. Now, A2 you find from here. What is A2? A1 minus 2G. Substitute here. So, M2 minus M1G is equal to M1 A1 plus M2 A2. m2 into a1 minus 2g. Okay. Now solve this, you will get your answer a1. And how to find tension directly using this? You find a1 and a2. What is a1 from here? Using this a1, t by m1 minus g. Okay, if you divide both sides by m1, t by m1 minus g is equal to a1. And what is a2? Tell me what is a2? Like this, g minus t by m2, correct? And a1, a2 you got, substitute here. So a1 minus a2 is equal to 2g, substitute. So t by m1 minus g, this is a1 minus a2, g minus t by m2 is equal to 2g. So t by m1 minus g plus t by m2 is equal to 2g. Now minus 2g, it will go to the right side, become 4g. So t by m1 plus t by m2 is equal to 4g. So now you solve this. So t common, 1 by m1 plus 1 by m2 is equal to 4g. Solve this, m1 plus m2 by m1 m2, m2 m1. So t is equal to 4 m1 m2 g by m1 plus m2. Correct? This is the tension. Clear? So this is a good question. It is important also. Okay. You practice this question again and again. Correct? Yes. So any doubt is there, you can discuss. So you practice this again and again. Okay. So that this question you will memorize. Ninth question. Same change in momentum. What is the formula for force? Delta P by delta T. Now delta P is same. Delta P is same. Delta P is same. So F is inversely proportional to delta T. If delta T is more, F is less. The same change in momentum about in x time needs y force applied. Here you have to write like x is it is like fill in the blanks. Okay, this question is like fill in the blanks. Like suppose fill in the blanks time needs fill in the blanks force applied. When time is less, force is more. So less time needs large force, or you can say, or more time needs small force. Are you getting? So they are calling x y like that. So shorter, you can call it shorter also, shorter time shorter time needs greater force. Longer time needs lesser force. So what is correct? Which option? Both are correct. 1 and 2. Both 1 and 2. Tenth question. There is a trolley. This is a trolley. Okay, trolley is going like this. Suppose this is the trolley. Tires are there. It is going like this. So what is the acceleration of trolley? A. Now box is kept on it. This is the box. Box on the trolley. Coefficient of friction is given mu s. Means the trolley surface is rough. Trolley surface is rough. You tell me, suppose observer is inside trolley. Now trolley is accelerating right side. So the box will experience pseudo force where? Left side. So what is the formula for pseudo force? Ma. So who will stop it from sliding? It is a rough surface. So what force will stop it? Friction. Okay. It's static friction. Correct or not? It is not moving. Trolley is going right side. Observer is on trolley. This observer is inside the trolley only. So this observer is seeing what? What it is seeing? Box is not moving. So pseudo force is left, friction is right. So it is a static friction. Maximum acceleration so that box does not slide. So you can check here. So if more acceleration means more friction, but friction has a limit. So when this is more, so you can note down. So if Ma is more, static friction also more. So but F has limit. Value of maximum friction, tell me what is the value of maximum friction? Mu s n, and what is n here? Mg. Mu s mg. Okay, clear? Now equate these two. So Ma must be less than or equal to mu s mg. Ma must be less than or equal to, okay, understood? Cancel. Both are same mass. Okay. So acceleration must be less than or equal to mu s g. Acceleration must be less than or equal to mu s g. Note down. See, acceleration of trolley right side, so pseudo force left side, Ma. So more acceleration means, suppose acceleration is 1 meter per second square, 2 meter per second square, 3 meter per second. More value means Ma will be more. So chance of sliding is more. More chance of sliding, correct? More chance of sliding. So friction will also increase. Static friction is self-adjusting. Static friction is self-adjusting, correct? So what is the minimum value of static friction? 0. Maximum value mu s n. So friction, static friction cannot be more than this. So suppose MA pseudo force exceeds this, so block will slide, it cannot be addressed, it will slide left side. But I don't want it to slide. Okay, block do not slide. Then what is the condition? This is the condition. Acceleration must be less than equal to mu s g. Okay, clear? Okay, note down. So mu s is given 0.3, g is 10. So maximum acceleration is 3 meter per second square. The shape of the boat is like this. Boat is like this. This is the boat. Aeroplane also like this. So why? It is aerodynamic shape, correct? Air friction will be less. Truck. What is the shape of truck? Truck is like this. The front surface of the truck is vertical, but aeroplane, it is like this is not aerodynamic. Aerodynamic shape. So what is the use? What is the use? Why? Air molecules. Air is there. So air molecules are hitting perpendicular to surface. In case of truck, so truck is experiencing force where? Left side. So are you getting? Air molecules are hitting perpendicular to surface. Surface is vertical, so force is where? Left side. But in case of boat, air molecules will hit like this, you know, air molecules are coming like this, but surface is not perpendicular to it. Surface is like this. This is the surface, tangent, okay, tangent to surface. Surface is like this, curved, and air molecule is coming like this. So draw tangent here. So the force will be perpendicular to surface. So force will be perpendicular to surface like this. So here force will be like this. Are you getting? So it is not opposite to motion. The boat is going where? Boat is going where? Right side. But force is not left side. Force is making some angle. Correct? So force is more or less? Less, because component will act. Like for example 10 Newton and this angle is 60 degree. So what component is acting? Left side? Cos component. So 10 cos 60 means 5. So 5 Newton is acting. But in case of truck, it is 10 Newton acting. Truck means 10 Newton acting here, but boat 5 Newton acting. Correct? So that's why air friction is less in case of this shape. So this is known as aerodynamic shape. Okay. So friction will be less. Air friction less. Less air friction when shape is aerodynamic. You can check it, like move your hand like this. You feel more air. Now you move your hand like this. Less air friction. Correct? Paper also, if I move the paper like this, more air resistance. If you move the paper like this, it's less air resistance. Okay, clear? So to reduce friction, twelfth question, 40 kg boy is hanging from horizontal branch of tree Suppose this is the tree, this is the branch of the tree. Now one student is hanging like this. Okay, it is hanging like this. So one hand is here, another hand is here. So one force is acting here, one force is acting like this, correct? Another force is acting like this, and weight is acting downward. Weight is downward. So both will experience same force, tension T. So now with vertical, what angle it is making? Suppose alpha, like this. This is T, this is T. Here is mg. Now what is this angle? Alpha. So what is the upward component? T cos alpha. For this also alpha. So T cos alpha. So net force upward 2T cos alpha, downward mg. Okay. Sine component cancel. T sin alpha cancel. They cancel each other. Cancel. So 2T cos alpha is equal to mg. 2T cos alpha is equal to mg, correct? Now what is the question? The tension is minimum. Now what is the formula for tension? mg by 2 cos alpha, correct? Now tension is maximum, tension is minimum. Tension minimum means cos alpha maximum. Tension is minimum, so cos alpha maximum. What is the maximum value of cos alpha? Maximum value of cos alpha 1. So what is alpha? If cos alpha is 1, what is alpha? 0 degree, correct. So hands should be vertical like this. Okay, hands should be like this, vertical. Both hands are parallel. Hands are parallel. Angle is 0. Okay, any more question you tell? Any more question? 20th question. You got the answer? 20th. Ball is coming like this. This is the velocity. At what angle it is hitting? This angle is given 60. So what is this angle? This angle. Angle of incidence. What is angle of incidence? 30. And what angle it is rebounding? Now this is 60. So what is angle of reflection? 30. So what is change in momentum? We have done in class. What is change in momentum for ball? Change in momentum for ball, tell me. We have done it in class, tell me. 2 mv cos alpha, correct? 2 mv cos alpha, plus or minus? This is V. So initial component, this is alpha, correct? This is alpha. So V cos alpha, V sin alpha here. Now this is alpha, this is alpha, so this is alpha. So left component, what is left component? V cos alpha. Upward component, V sin alpha. So what is initial momentum? P initial. What is initial momentum? M into I cap j cap. V cos alpha I plus V sin alpha j cap. Very good. And what is P final? P final m into V cos alpha minus I plus V sin alpha j. Yes, sir. Oh. So, plus V sin alpha j. Now, find delta P vector. What is delta P vector? P final minus P initial. So, this V sin alpha j cancel. So, minus mv cos alpha minus mv cos alpha, correct? So, minus 2 mv cos alpha I cap. Understood? So, this is delta P. So, force. Now, average force, what is the formula? Delta P by delta T, correct. So, minus 2 mv cos alpha I cap by delta T. Delta T means time of contact. Time of contact is 0.2 seconds. Time of contact is 0.2 seconds. Okay, substitute values. Alpha is 30 degree. Okay, angle of reflection, angle of incidence, angle of incidence, angle of reflection. Okay, theory question, 19 question. Tell me, 19. Answer. Directions. In the following questions, statement of assertion is followed by reason. Mark the correct choice. Assertion. There is no appreciable change in position during action of impulsive force. What is impulsive force? Change in momentum by time taken, correct, good. But what is the meaning of impulsive force? The force which acts in a very short time. Force acting for short time, very short time, very short time. The time is so small, like 1 millisecond, okay, 2 millisecond, 0.001, 0.002, okay, second. Time is so small, the position does not change much, okay. So, change in position is negligible or very less. Change in position is very less, okay. Change in position is suppose this is the football. What is the initial velocity of football? 0. Now player is there. So this is the player. It will hit the football. It will come in contact with football. It will hit very large force. It will exert. It is a large force. Okay. Time is less, but force is large. So force, it will exert force here. So force on the football is this way. Correct or not? Then contact will be lost because football will go here. So during contact time, okay, during contact, football will displace very slightly, okay. When contact is lost, football will go very far, but during contact time, maybe 0.002 seconds, football will shift very slightly. There is no appreciable change in position during impulsive force. So true it is. Okay. So note down. Assertion is true. Reason. In case of impulsive force, time is very short. Correct. So time is very less. So change in position is very less. So reason is correct or false? Correct. Reason is correct. Explanation also correct. Okay, clear? 18. Okay. Velocity acquired by mass in traveling certain distance d starting from rest under action of constant force. Okay, force is constant. Okay, initial velocity 0, after some time velocity v. Now displacement is given or time is given? What is given? Displacement or time? Tell me. What is given? Displacement. See, it is given certain distance d. After traveling certain distance d starting from rest. So suppose acceleration is a. So what? Which equation you will use? Displacement, initial velocity, final velocity, acceleration. U v a s. Correct. Good. V square minus u square is 2as. So substitute. So v square is equal to 2a. Now a can be written as f by m. Now force is constant. Force is constant. D is also fixed. D is fixed. So F and D both are fixed. So V square is inversely proportional to mass. So V is inversely proportional to 1 by root m. Clear? Okay. Okay, any more? Which one? 13. Yeah, yesterday we discussed this. Suppose this is the wall. This is the wall, this is the block. You are exerting force like this, okay? Like this you are exerting force. Okay, so what is the downward force? mg. Upward force? Friction. Left, capital F. Rightward force? Normal. So friction is equal to mg. So substitute, mass is given 2 into g. Okay, clear? 20 Newton. Friction is 20 Newton. Normal is F. Normal is F. F is given 100. So normal force is 100. Okay, clear? Yes, tell me. No. Mu n is the maximum value. Mu s n is maximum value of friction. Static friction. Maximum value of static friction is mu s n. What is minimum value? 0. Maximum value mu s n. So here no need to apply mu s n. Whatever is mg, that is friction here, because it is at rest. Block is at rest. body of mass 2 kg is kept by pressing to a vertical wall by force of 100 Newton. Okay. So, you are exerting 100 Newton like this, it is at rest. Suppose if they ask what is the minimum F, what is the minimum value of F, then you will need this. Yesterday we derived it. Friction is upward, mg is downward. So, to keep block at rest, then what is the condition? To keep block at rest, what is the condition? mg must be less than equal to maximum friction. mg must be less than equal to maximum friction, and maximum friction mu as n, and n value F, capital F. So, mg is less than equal to mu F. So, mg by mu is less than equal to F, are we clear? Or F must be greater than or equal to mg by mu, understood? So, F must be greater, suppose mg by mu is 10 Newton, suppose mg by mu is 10 Newton. So, F must be greater than 10 Newton or equal to 10 Newton, 10 Newton, 11 Newton, 12 Newton, okay. Then it will be at rest. Okay, next question. Sixteen. See, this is the spring. If left side it is fixed with wall and right side you are exerting force F, you are stretching the spring. So, right end will shift right side, this right end shift right side. What about left end? Left end, tell me. It is fixed, correct or not? So, why it is not going right side? Because wall is holding it. It is like this. This wall is holding this left end and I am pulling this right here like this. Understood? So, wall is holding it. So, wall is exerting force on spring where? Wall is exerting force on spring where? Right or left? Left side. So, this is the force on spring from wall. This is the force on spring from wall, okay. And what is the net, what is the mass of spring? It is massless, right? Spring is massless. So, net force is 0. What is the formula for net force? Mass into acceleration. When mass is 0, so what is the net force? 0. So, this is F, so this is also F. If this is 1 Newton, so this is 1 Newton. 2 Newton, 2 Newton, 10 Newton, 10 Newton, both are equal, and both are equal to a spring force, okay. This both are spring force, note down. So, both are spring force. So, this is spring force, okay, Kx, correct? Spring force formula Kx. This is spring force, this is spring force, both are same. So, that is also known as a tension. This is also known as tension. Suppose this is the spring, right side you are exerting 5 Newton. So, left side also what is the force? 5 Newton. So, what is the tension? 5 Newton. Tension is 5 Newton. Okay, clear? Any more question, tell me? body of weight W1 suspended from ceiling. This is the ceiling. So ceiling, body of weight W1. So this is W1. Through a chain of weight W2. Okay, so there is a chain. This is the chain. Weight of chain is W2, weight of box is W1. Ceiling pulls the chain by force. So what is the force exerted by ceiling on the chain? So that is tension here. So what is tension here? Total weight below. Total weight below. Correct. Good. So what is the answer? Total weight W1 plus W2. If they ask what is the force exerted by chain on the block, then what is the answer? W1. Next, tell me anyone? Any more? Okay, let's do one friction. So write down inclined push force. Inclined push. Like suppose there is a statement it is easier to pull than push. It is easier to pull than push a block using inclined force. Okay, so what is horizontal force and inclined force? So, see, suppose this is the what type of surface? Horizontal. So this is the block. So if you are pushing the block, it will look like this. So this is known as horizontal push. If horizontal surface block is there, now this is known as horizontal pull. Horizontal pull, both are equal. How much minimum is needed? Tell me. Left side, what is the force? Friction will act left side. Here also friction will act left side. So what is the minimum value of F to move the block? So F minimum mu s mg. Correct. Good, because n mu s n is mg. N is mg here. Small f is friction. Remember, small f means friction, capital F means external. So same formula for both, right? This is the same formula. So this is known as horizontal push. So horizontal push is same as horizontal pull. Both are same. But inclined, it is different now. Inclined will be different. So draw this diagram. horizontal push, horizontal pull, both are same. Now what do you mean by inclined? So let's check inclined push. So this is the block. Now force is like this. This is inclined push. What angle making with horizontal? Theta. So first you take components because surface is horizontal. Surface is horizontal. So what are the components? Tell me. What is the horizontal component of force? Force is like this. So what is the horizontal component? Cos or sine? Cos. Vertical component? Sine. So this is f cos theta, f sin theta, normal, mg, friction. Understood? Draw this diagram. Small f means friction. So what is difference now? When force is horizontal, horizontal push, what is normal? Mg. When force is inclined, then what is the normal? Sit. No problem. Okay. It is very common thing, no problem. So now what is this force? What is this force? Inclined or horizontal? Horizontal. Now what is the force? Now this is inclined. So this is inclined. Inclined means what is a normal? Tell normal. Mg plus f sin theta. Very good. So normal is more or less now? Normal is more. Are you getting? So horizontal force, normal is mg. Now inclined push, normal is more. So now to move the block, what is the condition now you tell? To move block, tell me. To move block, what is the condition? What is the pulling? Yes, correct, good. So along the surface, force is f cos theta. This is along surface. So you have to overcome friction. So to move block means to overcome friction, static friction, maximum static friction. That is also known as limiting friction. Okay. So f cos theta must be greater than mu s. Yes, correct, good. So f cos theta must be greater than mu s n, and n is this. Now substitute. So f cos theta must be greater than mu s mg plus f sin theta. Clear? Are you getting? It is looking very big equation, but it is easy. You understand step by step. When you exert horizontal force, what force you have to overcome? Mu s mg. So minimum force you have to apply mu s mg. Now f cos theta should be more than mu s mg plus f sin theta. Are you getting? Now find f value. F value find. So f cos theta must be greater than mu s mg plus mu s f sin theta. Now take this left side. So f cos theta minus mu s f sin theta greater than mu s mg. Okay, understood. Now take f common, cos theta minus mu sin theta, which is mu s, okay, is greater than mu s mg. So what is f? Now take this term right side. So f is greater than mu s mg divided by cos theta minus mu sin theta. So this is the formula. Okay, remember this. Minus sign is there. Okay, so minimum horizontal push or pull is mu s mg. Okay, mu s mg, minimum horizontal push or pull, and this is minimum inclined push, minimum inclined push to move block, minimum inclined push to move block. So mu s mg by cos theta minus mu sin theta. Okay, clear? Okay, copied. So this is known as inclined push. Inclined push, this is inclined push. So f cos theta is pull, f cos theta is acting right side, f sin theta upward, oh sorry, f cos theta right side, f sin theta downward, normal upward, mg downward, understood? And friction is left. So f cos theta must be greater than mu s n, f cos theta must be greater than mu s n, n is mg plus f sin theta. Solve, solve, solve. This is the formula. Now you consider pull, inclined pull. Suppose this is the block. Now you are pulling it like this. Like this you are pulling. This is pull, correct? This is push, pull. Or like this is also pull. This is pull. So what is this angle? Theta. So this is pull force, understood? Now take components. What is horizontal component? Tell me. Horizontal component, f cos theta. Vertical upward, f sin theta. Normal force upward, mg. Downward friction, leftward. So what is a normal now? N plus this is equal to mg. N plus f sin theta is equal to mg. So what is n? Mg minus f sin theta. Good. Now to move block, what is the condition? F cos theta must be greater than mu s n. N is this. So f cos theta must be greater than mu s n. Mg minus f sin theta. Now solve this. So note down, f cos theta is greater than mu s mg minus mu s f sin theta. So f cos theta plus mu s f sin theta is greater than mu s mg. Take f common, f into cos theta plus mu s sin theta greater than mu s mg. So what is f? Now take this term right side, denominator. F must be greater than mu s mg divided by cos theta plus mu sin theta. Okay, this is the formula. So this is minimum inclined pull. This is minimum inclined pull force. Minimum inclined pull force. So like this, you are pulling it like this. Okay. Minimum inclined pull force. So what is the minimum inclined push force? Mu mg by cos theta minus mu sin theta. And what is the minimum inclined pull force? Mu mg divided by cos theta plus mu sin theta. Okay, understood? So F minimum push is equal to mu mg by cos theta minus mu sin theta, and F minimum pull mu mg by cos theta plus mu sin theta. Okay, clear? And F minimum horizontal force, what is the formula? Mu mg. If push or pull horizontal, like this is horizontal, so horizontal means mu mg. Inclined push, okay, understood? Denominator minus for push, pull means plus is there. Okay, correct. Now one numerical homework. Now this is 2 kg block, mu s is 0.5. Find minimum horizontal push or pull force needed to move find minimum inclined push needed at angle 37 degree. With horizontal. Find minimum inclined pull. Okay, use this formula. Needed at angle 37 degree with horizontal. So first question you are exerting horizontal push, second question inclined push, third question inclined pull. These are the formula. First question formula mu mg, second question formula mu mg by cos theta minus mu sin theta, third question formula mu mg by cos theta plus mu sin theta. Okay, so apply this. When push is there, minus is there, minus. When pull there, the plus is there, denominator. Okay, clear? Okay, finish it. We will continue. Okay. Okay, we'll continue. Note down. Just copy a question. After break, you solve. Okay. Any doubt you ask.